No, it's funny when the girl goes on stage and she sings the song with her dad.
Ladies and gentlemen, boys and girls, children of all ages. All right, today we're going to do some problems that don't require you to do much math. Maybe a little bit of multiplying by whole numbers, a little bit of thinking, but nothing that is over your head. You need to be quiet or you need to leave. Thank you. All right, so we're going to talk about multiplying decimals today. If you can multiply whole numbers, you can multiply decimals. If you know how to read a multiplication chart, you can multiply anything, no matter how big the number. Our goal, what we're required to do by soon, is you are required to be able to multiply 3-digit numbers by 2-digit numbers. So one factor is 3 digits, one factor is 2 digits. That's where we're going to get. That is where we're going to get to. But for this particular video, we're just going to talk about where we're going to place the decimal point. And let me get my Team Shake app because I paid
99 cents
for it.
$99.
And I want to get,
$99 more dollars by it.
need to get my money's worth.
It's worth $1.
Let's see.
It's worth
Those of you trying to entertain during the video, that's my job, so please stop. So Isabel, let me ask you a question. If you had to use some of your thinking and common sense, some logic, where do you think the decimal point would belong? Our first factor is 3 4/10. Our second factor is 5 2/10. Our product has a 1, a 7, a 6, and an 8. But it's going to have a decimal point somewhere. After the 1. And why do you think it's after the 1?
because the other two problems they have the decimal point after the whole number.
Okay? The other two problems have the decimal point after the whole number. Sophia, why is she not here?
I don't know. She's never here.
Why aren't you here, Sophia? Daniel! Daniel, where do you think the decimal point should go?
Behind the 7,
Behind the 7. Why, Daniel?
because 3 times 5 is 15.
Because 3 times 5 is 15. And where did you get 3 and 5? So you just took the whole numbers? How'd you get 3 here? Good, you rounded to the nearest 1, right? The nearest whole number. And 3/4 is closer to 3 than 4. 5 2/10 is closer to 5. And since 3 times 5 is 15, my whole number needs to be somewhere near 15. So that is where he came up with that. Caden.
Oh, never.
Never mind Caden. So he used some rounding to get an idea of what my whole number would be. Where's my decimal point? Silas, in the number 15, where's my decimal point? After the 15. Every number has a decimal point. If we know the 5 is in the ones place, my decimal point always falls after my ones place. So if I know 5 is in the ones place, so according to Daniel, if 3 times 5 is 15, and he rounded these, my whole number needs to be somewhere around 15. If I put my decimal here, what's my whole number? If I put it here, what's my whole number?
17.
If I put it here, what's my whole number?
17 and 10. 60.
176. And if I put it here, what's my whole number?
1,768.
Good. So the only one that makes sense would be 17 as my whole number. Again, we're not doing any math, really. I mean, you had to do some estimation. I wouldn't call multiplying 3 times 5 actually having to work any math because, boom, it's in your head already. And if it's not, go home tonight and ask your mom to cook up some multiplication problems for dinner, eat them, and then it'll go straight to your head. Or sleep on a multiplication chart. I don't care.
Are you getting answers off your phone? He's getting answers off his phone. No, he's not.
Off the paper.
Here's a piece of paper.
All right, let's look at this one and let's go. Aiden. Aiden, how do you say this factor? Zero and 9/10. Good job, Aiden. Zoe, how do you say this factor? Oh my gosh. Zoe, where are
He
you?
has it in here already.
Natalie, how do you say this factor? 2 and 46 hundredths. Good. So we have 0 and 9/10 multiplied by 2 and 46 hundredths. We know these numbers here are in our in our product. So Chase, where would you place the decimal point?
Right behind the right in the middle of the 2 and the 1.
Right between the 2 and the 1. Why would you place it there, Chase?
Because common sense, it's more likely not to have like 2 times 9. 2 times
Well, what is 9/10? If I was rounding that to the nearest whole number, what would it be?
0. No, it would be 5.
No. 9/10. I'm rounding to here. Find my number, look next door.
1.
So it'd be 1. Good.
And then it's not, most likely not going to be
What's this round to? 2 and 46 hundredths rounds to?
2.
2. And 1 times 2 is?
1 times 2 is 2.
1 times 2 is 2. So you think this is going to be 22 and 14 hundredths? Well, you just estimated that this equals 1, right? You just estimated that this rounds to 2, right? So this is close to 1, this is close to 2. And 1 times 2 is?
2.
But you're telling me close to 1 to close to 2 equals 22? So where should my decimal point be, Chase?
At the right between the 22.
Between the 2's. Good. We use some rounding, which we've learned. And we use some thinking, which I'm teaching you now because you've probably never thought before. Except when you get up in the morning and you go, oh my goodness, what am I going to wear to school today?
I do that every day.
I really don't want to wear that because last time I wore that, he never even looked at me. He didn't think I was beautiful.
I choose not to use my brain.
Let's look at another one.
If I had next time, I would have had Why? I'm so weird. Maybe it was my bad.
You're confused because you haven't been really paying attention. Tristan, how do you say this one? This factor. 9 and 1/10. Phoenix, how do you say this factor? 5 and 7/10. So we want the product of 9 and 1/10 and 5 and 7/10. Taylor. She's not here. Yes, she is. Stop telling me that. Taylor, where do you think the decimal point should go?
I think after the 1.
After the 1, why?
Because I rounded 9.1 to 9 and 5.7 to 6.
And 9 times 6 is?
54.
54. This is why estimation is such an important math tool. Estimation is such an important math tool. If I was driving somewhere and it said it's going to take me, let's say, 5.2 hours, that's different than it's going to take me 52 hours. So I would want to understand what's more reasonable. I don't want to drive somewhere, oh, man, I have to be there by 8 o'clock tonight. But it's going to take me 52 hours. That doesn't make any sense. You can pretty much drive anywhere in the United States in less than 52 hours, unless you're driving a moped. Or a lawnmower, yes.
No, a lawnmower is not as faster. A lawnmower is also not as fast.
You don't know that. Let's look at one more.
Why do you hate mopeds?
And Uber, they're not fast.
Yeah, they are.
I've been Uber this late.
And let's call on Zen. How do you say this factor?
4 and 8 tenths.
I will be next.
And Ashley, how do you say this factor? 6 and 1/100th. 6 and 1/100th. And Nathan, where do you think my decimal point's going to go?
After the 28.
Why after the 28?
Because 6 times 4 is 28.
So you rounded this to 6, and you rounded this to what?
5.
To 5. And 6 times 5 is? 30. And 30 is close to 28.
Are you sure it's not close to 288?
I'm sure it's not close to 288. So that's using estimation to tell us where to place the decimal point. In a moment, I'm going to give you some notes that you're going to glue in your journal, which is going to tell you why you put the decimal point there. Why you put the decimal point there. ¿Por qué you put the decimal point there? And actually, let me tell you before I give you the notes. 2, 8, 8, 4, 5. So if we had this problem, this is our multiplication problem. If you want to know why you put the decimal point where you put it, you look at your factors. In your first factor, 4 and 8 tenths, how many numbers are to the right of the decimal point? 1. That was a trick question. I know it was hard. And if we look at our second factor, 6 and 1/100th, how many numbers are behind the decimal point? 2. So how many total numbers did I circle? 3. That's how many numbers need to be behind the decimal point in my answer.
Wait, what?
Whoa.
What?
We do not line up
Confetti.
the decimal points when we multiply. We do not line up the decimal points when we multiply. We don't have to annex any zeros. The rules that you're going to glue in your journal are going to say multiply it ignoring the decimal points. So I would change this, multiplying and ignoring the decimal points, to 601 times 48. Then when I got my product, then I would place my decimal point by counting the numbers to the right of the decimal in the problem.
And that is math.
Yes, ma'am.
Why wouldn't you line up your numbers?
Because when you multiply, you don't have to.
But can you?
Then you're going to make the problem, if you line up your decimal points, you're going to make this problem 601 times 480. Is that what you want to do? No, because you're adding a whole nother line.
But I thought whatever times 0 is 0, and then
Yes, so you're making all this extra work just to put a zeros here. It's not if you have just zeros in one of your lines of your product, it's not going to change anything, is it? How's it changing anything?
No, I said no.
Oh, you said no. Thank you, Chase. Sorry. So you're going to glue some notes in. And then on the notes, there are 4 problems. They're all really easy.
Yay.
If you use a little bit of thinking.
I don't like to think.
Sorry. I got to teach you that.
He's about to peace out. Peace out time.
Boom! Shakalaka! Peace out. God bless. Love ya. Do something kind.